Hey everybody, my name is David Burkett. I'm a cloud security researcher at Corelight, and today we're going to talk about evading cloud container runtime monitoring tooling and the role of network detection and response in the cloud. It's a really interesting topic because there's not very much information out there. Most of the cloud network detection related write-ups are from the perspective of host-based tools, which have a lot of different caveats, different metadata that's collected and available. And it really means that whenever it comes to network detection in the cloud, I really get to be on a lot of the cutting edge stuff, which is a lot of fun. As I mentioned, I work for Corelight. If you're not familiar with this, Vern Paxson, the creator of Zeek's one of our co-founders. And if you're not familiar with me, again, my name is David. I've built a couple of security operations centers now. The last one that I managed, the security program for the organization, we won a Cogswell Award for being one of the top 1% of security programs in the classified and cleared space, something I'm really proud of. And I also co-authored one of the first public white papers on doing detection as code back in 2019. I think he started it back in 2018. So I've been doing detection and response for quite some time now. But let's get into the actual meat of what we're going to talk about. If you've been keeping up with the latest intel, there was recently a CISA joint advisory that discussed China or Chinese nation state actors were evading EDR tooling. They were specifically targeting things like edge devices, such as VPN appliances or firewalls, things that just specifically can't run EDR. And a big reason for this shift and pivot is, well, obviously attackers are always going to look for ways to evade security controls. But the reality is, EDRs have gotten so good that they've really made the life of an attacker on an endpoint difficult. We, as a security industry, have started getting those behaviors down, like the things that the adversaries need to do to execute code, and then investigating them whenever it comes to a system that we can actually see the telemetry for. The problem is there's a lot of things that we either can't or they just don't provide telemetry, such as IoT devices or just things along those lines where, again, we can't run that EDR. So these are the places that adversaries are starting to live. And it's something that if we in the cloud world, it's something that we should start preparing for. In my mind, the cloud workload protection tools or the cloud container runtime monitoring tooling is even more effective than EDR. Containers have the benefit of having the visibility from pre-deployment to deployment. They're often immutables, meaning there's not a lot of change that actually happens. So just change in and of itself can be identification of something malicious or suspicious. And with that, you can definitely expect that if your red team hasn't already been using some of the techniques that we're going to talk about today, you're probably going to start seeing it in the near future for all of the same reasons that adversaries are evading EDRs and endpoints. And again, it's because that visibility has gotten so mature on the endpoint. And a mantra that we've probably all repeated, myself included, is the cloud is just somebody else's computer. So if I have cluster admin, that's not really any different than if I have admin or local admin on a Windows system or root on a Linux machine. I can go through and I can do things like kill the EDR, uninstall it, whatever it might be, add firewall rules. The same things apply to a Kubernetes cluster. If I, for example, have a privileged pod or a privileged application that's running, maybe there's a supply chain compromise in the container. Maybe one of the software libraries, again, gets a supply chain compromise. Maybe an admin accidentally downloads a backdoor piece of putty or a tool called putty or some other kind of management tool. There's all kinds of ways that attackers can get this admin access that they need. And again, if they get the admin on a Kubernetes cluster, they can do all the same damage they could on a traditional host. So, for example, your cloud workload protection tooling is probably going to have to talk to a SaaS console. If you block the tooling from communicating to that SaaS console, you can't get alerts anymore from that tool. And that's the case whether it's EDR or container runtime tooling. And because of this, we need some other way to get that visibility in case this happens. So, and we can't rely on all of our security controls. As we can all attest, things fail, and we need to have backups. That's the whole concept of having these detections in depth and overlaying your detection capabilities and having overlapping security controls is for the case when one of those fails. And one of the things that's really key to keep in mind, the purpose of this talk is not to make the case that NDR or is better than container runtime monitoring tooling. I don't think that that's necessarily the case. They're both complement each other. Ideally, you would have both in a real world. So that's not something that you should take away from it, in that, maybe NDR is better or in an either or scenario, but really the idea is getting both. So again, we might have attackers blinding our Kubernetes cluster. They might modify those config maps, whatever it might be, and that can cause those tooling to stop checking in with us. Now we have a blind spot in our cluster. This would be no different than if they were interacting on-prem. So maybe they, or for example, have just hidden one malicious container rather than blocking the whole node. And your container workload protection, it's still communicating out. Everything looks fine, but it's just not monitoring the specific pod that the attacker is controlling based on their ability to modify the config map, for example. So something to just keep in mind. So let's talk about network detection in the cloud. One of the things that it's important to know is whenever you're monitoring these managed Kubernetes clusters, you're not really gaining or losing any visibility whenever you're compared to what you're doing on-prem, with one exception. The Kubernetes API that you're probably used to working with is not going to typically be available in a cloud network tap. And the reason being is because they manage that infrastructure for you. So you're typically interacting with that cloud console, and that's not traffic that you can tap, because that's basically going through in the internet. So it's something to keep in mind. But through the use of your guard duty logs or something along those lines, that could be a way to keep on that blind spot. But with that, you can still see your node-to-node traffic just like you could on-prem. That's no different. Attackers still have to interact with their compromised infrastructure. Again, no different than on-prem. So there's going to be that network communication. If you have network detection and response tools, one of the first things that I kind of run into whenever I talk about doing network detection in the cloud is everything's encrypted these days. And they're right. Everything is encrypted these days for good reason. And one of the things that network detection and using Zeek specifically for network detection and response in the cloud, it gives you so much network metadata that you can actually do really powerful detection. And there's a ton of stuff that you can detect despite encryption. And it's a lot easier than you might think. So, for example, one of the things, and I think I might have mentioned this in the prior slide, is container runtime tools. They benefit from the fact that containers are traditionally deployed as immutable runtimes, so they're not going to change in the environment, and that can really benefit us as defenders, meaning we can baseline the behavior of a container or an application much, much easier. That means whenever you're looking at the destination ports, for example, that a container might use or call over, having those baseline can provide a super high value way of detecting stuff, even if it is encrypted. Despite that, you're getting all of your DNS requests, you catch all your sitting tunnels through DNS, ICMP, all of these other various protocols, the TLS data that you can get, like such as the SNI, is really powerful. For example, whenever maybe attackers or malware is trying to communicate out to a mining pool, for example, and have that traffic encrypted, but maybe they're not, making a DNS request. They have some sort of hard-coded connection or something. There's all kinds of reasons. There's also been the advent of JA3, JA4, something that we maintain at Corelight is the hash SH, which allows you to go through fingerprint SSH connections. Again, that's super powerful in the cloud. If you look at the recent CISA joint advisory, one of the recent Chinese threat actors was using the custom SFTP tool, which, if you're not familiar, uses SSH under the hood, allowing you to, if you have a hash sh or Corelight. It is an open source package that you can add if you have Zeek. You can start fingerprinting the SSH connections in your environment and getting an idea of what kind of actual SSH agents there actually are. And that, again, becomes a powerful baseline despite being encrypted traffic. Like I mentioned, take advantage of the cloud and the fact that a lot of this stuff is going to be immutable, despite the cloud infrastructure typically being elastic, meaning it could scale horizontally. That typically doesn't really translate to much difference when it comes to the network behaviors, other than it might have more source IP addresses, but you can handle that through things like subnets or other metadata that you enrich with your network sensor. So, for example, Corelight, if you're monitoring your network with the Corelight sensor, we go through and pull out the IP addresses from your cloud network provider and then enrich them with your con logs, and it gives you a whole bunch more information on which VPC is calling from which IP address to which IP address. And it can just be so much more useful. Whenever it comes to cloud network detection and really just network detection in general, context is everything. And really, I would just say even just detection as a whole. So let's talk about the situation. So let's say you can't tap a network. You're not out of luck. There's something called VPC flow logs. You can think of these as the cloud equivalent of NetFlow. They contain a little bit more data, such as some cloud-specific stuff. So instead of just being your 5-tuple of your IP address ports and stuff, it's going to also have things like your VPC IDs, subnet IDs. Just depending on the cloud provider, it'll have different information. But one of the recommendations I typically recommend is use later versions of VPC flow when possible. There's I think version 2 is enabled by default, and it contains just some very minimal metadata, but each version that increments all the way up to, I think it's up to VPC flow version 8 now, has more and more metadata. And if you're going to be limited to VPC flow, again, context is king and everything. And the more that you're able to get that context around those network connections from that VPC flow data, the more detection opportunities that you're going to have based on that network data. And one of the, again, the big benefits of a tool like Corelight is we can actually stitch together those VPC flow logs. So if they have too much log volume or something, it really reduces the amount that you're actually ingesting, allowing you to ingest even more logs than you could to begin with. So one of the cool things that we're actually doing is we're turning those VPC flow logs into con logs, like you can see in the screenshot. And you can then use those logs to go through and write Zeek scripts against it. That makes it just so much more powerful. It's a lot of fun. And one of the other kind of things that stitching together that we can do, it will really reduce the log volume. I think the stats show up to 90%, but that's probably optimal network traffic. I would say it's definitely still up there, though, closer to the 50, 60 plus consistently. But, hey, who knows? Maybe you'll get lucky and it'll be the optimum case. But regardless, NetFlow is out there, VPC flow is out there, and it could be a very powerful detection capability. And of course, you have all your typical traditional IOC-based detections that you can do around those. Again, context around those will really help drive up your fidelity, minimizing those false positives, because IP address alone as an indicator of compromise, those are pretty prone to false positives. So we talked about some of these already, but let's go through some detection starting points for if you're doing network detection and response in the cloud. Like I mentioned, there's almost nothing out here when it comes to NDR in the cloud. This quote by Rob Joyce is just really so prescient because this same concept applies even in the cloud. So, despite me even saying earlier, it's just someone else's computer, it's all in the cloud and stuff. For some reason, we really think as an industry that there's going to be a lot of massive differences, and in a lot of ways that there are. But when it comes to some of the traditional and foundational security controls that you're going to want to implement, things like network security monitoring, a lot of those have established benefits that still are useful in the cloud for the exact same reason. So, for example, there's this famous quote from Rob Joyce. You're all probably familiar, former director of NSA, but he said something along the lines in the past of, one of our worst nightmares is that a threat actor has an out-of-band network tap capturing our network data. And basically, for those that aren't familiar, an out-of-band network tap just means it's not set in a configuration. So you can't tell that you're actually being monitored through that network traffic because from your adversary's perspective, perspective, there's no visibility into it, which is very makes it very difficult, or makes life very difficult for those threat actors. So why not do the same thing in the cloud? And while you can't necessarily get that out of band network tap in the same way, you're limited to more like VTAPs and span ports. The concept is still the same, and you still get a lot of the same benefits. So let's talk again about some of the detection starting points. So again, hit on this earlier. Cloud traffic, just because of its nature, again, in immutability, it's going to be much more consistent in its behavior. So you can have those easier baselines. One of the really strong ones that I pointed to earlier was baselining the destination ports that your cloud infrastructure uses. If you can do it down to specific applications, that could be so powerful. It can knock out entire classes of detections. Attacks. So rather, like, for example, let's say if I have a reverse shell, if I'm using any port other than the one that your app communicates out over, regardless of if my communication over it is encrypted or not, I've just detected that activity. You tie that back to the process that made the request, and boom, you've got a really good detector there for you. Becomes super hard to evade, makes things like scanning really difficult, really powerful. Use something like the peak threat hunting framework if you've never done baselining before, and that can go through and give you a structured approach to doing things like finding some of these baselines, building some of these anomaly detections, and having it documented in a really great way. Another thing that's really common, and this has always been really interesting to me, we'll see these supply chain attacks with hundreds of millions of downloads. I think maybe some of the big ones have even potentially had like 1 billion downloads. And it seems like the threat actors always just deploy a coin miner for some reason. Despite that, I'll take it. Coin miners have to talk out to the mining pool. That opens up detection opportunities. Suricata out of the box, just because this is such a prominent threat, has these pretty well covered, which is a really great, again, benefit for NDR tooling. Not only that, but if you have something like the Zeek metadata, there's so much that you can do to just get some of those like mining pool, just writing simple SIM rules against that metadata on like the TLS SNI. There's just so much opportunity there for detecting those coin miners. And another thing, and this goes back to kind of what I touched on earlier, enrichment in context is everything, especially whenever it comes to network detection. So whenever we're thinking about network attacks and cloud attacks, one behavior that adversaries use is they'll use things like Tor, they'll use consumer VPNs, like a commercial one that you might just go buy as a regular everyday person, or they might use things like Telegram, Discord, Steam, just these services to blend in that are legitimate, not necessarily malicious, maybe with the exception of Tor to a lot of people, so that are not inherently malicious. But if you have some of that enrichment that allows you to go through and do things like finding some of these some of these services that are probably not likely to be legitimately used in your environment. Like I've really struggled to think of many organizations that have like an enterprise application that needs to speak to Telegram without it being more of an exception than the rule, easily something allow listed. Same thing for Steam. So if you add a lot of these contexts, such as things like the user VPNs, ASNs, there's all kinds of stuff that you can add to this metadata that really raises the bar again for the adversary. So again, like if they're using VPNs that are consumer grade, probably don't need to be talking to that. Maybe one of the things that threat actors are doing now is they're compromising, small office and home office routers and using that as a pivot point for their compromises. A lot of network applications or a lot of enterprise applications never need to actually speak to a residential address, and just having some of that enrichment data can be so powerful for detection. And just getting some of that enrichment and some of that context, again, being king, gives you so many opportunities for baselining and detection. So even if that traffic is encrypted, you can detect stuff that you would maybe otherwise miss. So that's going to be my talk for you guys today. I hope you enjoyed it. Again, my name is David. I'm with Corelight. You can follow me on LinkedIn. I'm happy to answer any questions, and I look forward to participating in the Q&A with all of you. Thanks for joining me today. Thanks so much.